Okay, now it's recording. So yeah, just I just repeat it again. So we convert HTML to Markdown. The content is coming from Salesforce. Then we extract the summary of the content. Then we extract the situations, and every document can have multiple situations. And situations just refer to the scenario that the document can be referred to, or document can help the agent to solve. So for this, and also like we created different retrievers from this. Some of them are only using the fields that are already provided with the knowledge. So for example, content C is the content of the knowledge article. Or detail C is the exact equivalent on NBS. So we have eight retrievers. I assume 1, 2, 3, 4, 5, 6, 7, 8. So four for NBS and four for Sonnet. So basically, a summary will be one retriever. Situation will be one retriever. The title is just the title of the document. It's not generated by LLM, it's just the title of the document. And we have a couple of metadata as well. These metadata are knowledge article ID, the title, language, things like that. So we need these metadata just to filter in production. And how it look like this is the local Qdrant server that I have here. It's on local host. This is everything is on my local machine, but this will be AlloyDB in production. So AlloyDB has exact same um, embedding model, the same search, everything will be the same, but on my local machine, I'm just using another vector store. And if I go to one of these retrievers, so MBS KB situations, these are all the um, content and all of the metadata, right? So you have language, you have title, you have knowledge article ID. And so we have all of these, and Pooja and Rohan are working together to create a pipeline so that any content that changes, we go over all of these pre-processing steps and push it into AlloyDB and also Agent Builder. So what is the difference between the semantic search that we do in AlloyDB versus Agent Builder? So Agent Builder is just an enterprise service that is doing semantic search, but it has other features as well. So it has, for example, query expansion. It does everything automatically. And it's a service by Vertex AI, it's serviced by GCP. It does everything automatically. So you just give it raw text. It will embed everything. It will create a search engine basically with all of the features like re-ranking, like query expansion. There, it has lots and lots of features. And why do we use both of these? It's because of all the experiments that we did. It's just pointing us in this direction that only using semantic search gives us 40% accuracy. Only using Agent Builder gives us 38% of accuracy. And I will talk about how we calculated all of these percentages and how these are just very relative. But combining these two together gave us the best result, which was like 60%. And yeah, so in addition to that, document, this is very, very high level. It just talks about all of the retrievers that we have. But I'm gonna talk about the document that we created for testing all of these and just how we decided to go with this approach. So if you go to test artifacts and a sprint tree, or like the last sprint that we did testing, you can see all of the experiments that we did. And also If you are more curious and want to go deeper into each of these approaches, there is another document. It's called RAG experiments. I'm going to talk about that as well. So let's talk about a couple of examples of these tests. So for example, we evaluate the retrievers using Claude Opus, right? And what was the approach to create the ground truth, right? So we have an extracted situation, right? And we want to retrieve a couple of documents. How can we understand if those documents are the right documents? Um, for that, we need a ground truth, right? So for generating the ground truth, there are multiple ways to do it. But this is one of the experiments that we did, and this is how we did it. So basically, what we do is we send each of the documents to Claude Opus, and then say, is this relevant to the extracted situation, right? And then Claude Opus say yes or no. If it is yes, so let's say we have 300 documents in Sonnet for English, only English, and it gives us 10 true. So 10 documents are like LM thinks that these are actually relevant to the transcript, to the situation. We get those documents and we use that as our ground truth. Okay, so um, this is the first approach. There are other approaches as well, so I encourage everyone to go over each of them, and then we generated all of these scores based on the ground truth. So for example, for semantic search, we added the titles to the mix. So we have summary, situation, the raw document, and the titles. And then the number of documents that are retrieved is almost like 31. Like the median number of document retrieved is 31. And why is it changing? It's because we have an extracted situation, and we are in parallel. We are coring all of these retrievers, like 4 retrievers in this case, right? And not everything is unique. Like we get duplicate document IDs from the retrievers. So, and from each we get 10 documents. So instead of 40, it would be 31. So the median number of documents that are retrieved was 31 in this scenario. So we had Elasticsearch. We removed Elasticsearch because it didn't provide any value to the mix. But we have, for example, Agent Builder here. And so you can see the number of median documents that retrieved, and you see the union. So we add all of the document IDs that retrieve from semantic search and all of the documents that are retrieved from Agent Builder, and you can see the median number of documents increased. It means that these two are getting different document IDs. Like the input is the same, but the output are different. So instead of like 31 and 32, it's actually getting 48. So it's getting more documents. And the documents are about 500 to 1,000 characters. So we're not doing a splitting at all, just because they are at the right size. So we don't want to split the content so that like in the there are a lot of issues with splitting the content. And the good thing about the knowledge base is the documents are short, so that we don't need splitting. And then, for example, in here, we added re-rank to the mix. So for example, the re-ranker is a service. There are multiple services out there that does re-ranking, but we're using GCP re-ranker API. So we give all of these documents. So let's say 48 documents, and we ask the model to re-rank it based on the context, and it will give us top 10 or top 20. And you can see that the 61% with 48 documents can reduce to 51%, but with only 10 documents. So in terms of latency, 48 documents, it would increase the latency by a lot. So we can add a re-ranker at the top and get only top 10 documents, and the the accuracy is somewhat comparable. It's not like 61%, but it's 51%, which is good enough. For top 20, it's like 56%. So yeah, just a general idea of about like all of these experiments that we did, and you can also go through the files themselves. I know if I click on it on Confluence, it will show up weird, but I can show you one of them if I have the name of the document. Let me see if I can find it in my local. So if I paste it in my local, I can show how it looks like here. Just a second. So far, anyone has any questions, anything you want to mention? Okay, so this is one of the experiments, and you can download it in Confluence. It's all accessible. It's just that the preview function is just very messy. I don't see the columns, and I don't want to download it because I already have it on my local. So you can see all of these things here. So one thing to mention is the transcripts comes in. So this is how the whole system works. The transcripts comes in, and we want to emulate the streaming element of the actual system, because we don't have the full transcript, right? When we want to generate a pop-up, we don't have everything. So we have just a sample of the transcript that is growing over time, right? And then for each of these transcripts, we have multiple situations. So it's not, the extracted situation is not just talking about the main topic of the transcript. It has like 3 sentences, then it has 6 sentences, then it will grow over time, and extracted situation changes over time, right? So you have the first situation, then you get the second one, then you get the third one, and also you can see the retrieved documents, everything that was retrieved. And with the name of the file, you can actually go in the experiments and find what was the actual approach, right? So these names are consistent. And then you can see ES means the Elasticsearch. So retrieve documents by ES, retrieve documents by Agent Builder, the union, and then you can see the unique ID of the transcript, and you have a session ID as well, and then you have the ground truth. And again, if you go over the document, you can see how we generated the ground truth. So we have ground truth citation, we have ground truth retrieved docs. So the difference between ground truth and ground truth citation, and also the ground truth retrieved docs, is that the ground truth itself, like the pop-up that we call ground truth, is using all of the context. It's a very expensive call, so we don't do it often. We just have it for a sample of the transcripts. So it means that LLM has the full context of all of the knowledge bases. So you first do a filter, you show all of the documents to the LLM. You do like 300 calls to LLM. You gather all of the documents that are relevant to the extract situation, and then you generate the pop-up, and we call this ground truth. And this is the ground truth pop-up, and it is different from ground truth retrieved documents. So the ground truth retrieved documents are only the documents that the LLM thinks they are relevant, but we didn't actually generate the pop-up. This is just a list of all of the documents, and the ground truth itself is just the next step as well. So it's just a full RAG. And there are a lot of things here, and then after these, you can see which ones got 0, which ones got 1. So accuracy of retrievers, Elasticsearch. This is agent builder. This is the union. So you can see all of them. And then if you want to average them together, you can to see the final results, which are also reported in here. So that's about the experiments that we ran. So I'm going to continue with the approach. So I talked about the retrievers. We are using semantic search and agent builder. Although I have to add, this is not only semantic search, it is semantic search plus re-ranking. So, but the thing is, we get all of the all of the document IDs from semantic search. We get all of the documents from agent builder, and then on the union of everything, we do a re-rank. But yeah, I forgot to add it here. I'm gonna add it here as well. So let's talk about the full RG. So we have two RG systems. The first one is RG from the knowledge base. The second one is RG from Guidewire data. So RG from the knowledge base is exactly as I explained. You have a transcript that is running and it's growing over time, right? So you send it to the LLM to extract the situation, right? So you get the first situation. It is extracted from like 3, 4 sentences. It's just the beginning of the call. And then after like the few sentences, you do it again and again and again so that you have multiple extracted situation, right? So the second step is situation comparison. Because if we just want to send one pop-up per situation, the agent will see a lot of pop-ups. And most of the pop-ups will be similar because the extracted situation doesn't change every 3 sentences, every 4 sentences, right? So the extracted situation only changes when the topic of the call changes or there are a lot more, significantly more information. So we compare the newest, the current extracted situation with all the previous extracted situations. And then if the similarity is less than 90%, and I'm talking about semantic similarity and semantic similarity with the exact same text embedding model that we use everywhere. So we do a semantic check with all of the previous situations. And then if it is um, less than 90%. If it is more than 90% similar with all the previous ones, we just ignore it. Because if we go through the whole LLM stack and retrieving information, we will get exactly duplicate pop-up, and we don't want that, right? So we want to only query LLM whenever we have an actually new situation or more complete situation. So if the similarity is below 90%, and this 90% can change in the future, but this is just the first number that I actually tested a few numbers, but 90 was looking good, but I'm going to talk about how we're going to change it in the future. So basically, if the similarity is less than 90%, we go to the next step. So it means that we have a new extracted situation. So we do two things. We retrieve all of the documents. We go through retriever system, right? Semantic search, agent builder, and re-ranker that I explained before. And then this is the last part, which is we have a bunch of document IDs. We just go and grab the actual documents. We send extracted situation plus the documents to LLM, and we generate the pop-up. That's the last step, right? And right after this step, there are a couple of other steps as well, but this is not going to be in the RAG. It's going to be on the Flink documentation that we're going to generate. So this is the whole knowledge base RAG. The second one is on Guidewire data, and everything is similar, except instead of like querying the knowledge base, we're going to query Guidewire based on the extracted policy number. right? So we extract the policy number from the transcript, and the agent can edit the policy number as well in the UI. But we somehow get the policy number, whether from the agent or from the transcript, and then we query Guidewire. We query the policy center and billing center, and then we send the extracted situation plus all of the data from Guidewire to generate a pop-up. So that's about it. Like this is the high level of the whole RAG system. So is there any questions so far? Also, did I book this session for 1 hour or is it 30 minutes? I don't remember.
I think it's 1 hour.
Oh, 1 hour. Okay, so we have time. Okay, Neeraj, do you want to go first?
Yeah, no, I do have a lot of questions, but I was wondering if we should just continue your
Okay, sure,
knowledge
okay.
transfer.
Okay, so I'm not gonna go over the code itself because the code that we currently have will change dramatically, just because the code that we currently have is the experiments that we ran, right? So we have the experiments, we have all the tests, we have the code, but if we want to like push it into production, everything will be on Flink, which is the next step. And if you want to see the actual experimentations, just a second, I can show it to you in here. Yeah, so there's a Bitbucket repo. It's called Agent Assist. Hopefully I can log in. Okay, I'm not logged in. So basically it's a branch. It's called Exploration Do Not Merge on Agent Assist repo. So if you want to take a look, and I have a README file here that I explain how we generate the pop-ups, how we evaluate the pop-ups, how we generate the ground truth, the testing, and the path to different Jupyter notebooks, and also the Py files, if you want to take a look. So that's about it for RAG. If there's no questions, I'm gonna go over Arise a little bit. Okay, so regarding Arise, so Arise is just a traceability and evaluation platform, but I think the most useful part of it is just the tracing, right? So if you go to the platform, you have data set, you have tasks, you have dashboards, you have monitors, you have a lot of things here. But in my opinion, the most critical part of it is just the traces. So I have a couple of projects. I'm going to go to one of them, and I'm going to go to LLM tracing. So this is very, very similar to Langsmith. I don't know if anyone in the call has experience with Langsmith. This is very, very similar as well. So basically, we are using LangGraph on the backend, and LangGraph automatically generate these traces, right? So, and these traces can be very, very huge. And this is only a call. This is one call. This is not like multiple calls, and it can be huge in the backend. So I'm gonna go over one of them, and that's why like platform like Rise can be useful. So I'm gonna go to the most like the deeper level and then go up. So here I'm gonna go over, for example, this call to Azure Chat OpenAI. This is public data. It's not sensitive, so we can just take a look at it. So here, I'm calling GPT 2.5 Turbo, right? So there's an input and there's output. And the output is like an pydantic object with a variable. It's called answer exists in context, true or false. So basically, we're asking the model uh, if if the answer to the question exists in the content in the documents or not. And then it will give us an answer. And the good thing about it is you can go to the raw output as well. And this is the raw output that you get from OpenAI, right? So you have the prompt tokens, you have total tokens that were consumed, and you have the latency here, right? So very, very important. You have the latency here. So 542 milliseconds for this call. And then you can go to the next level, which is, for example, you have a parser that parse Pydantic object into um, just the text, pure text, right? So you wanna do that, and then you can see that the latency on that particular object as well, right? So you can actually go deep into your chains, and the chains can get very, very deep very easily. And it would be very hard for everyone to just point out what was going on, like what went wrong. If you get an error, you don't know which part of the system gave you the error. Was it the parser, or was it the OpenAI? Was it something to do with a Lambda function that you have? And also for optimization, for example, if you want to optimize the whole stack, you might think if you just change your model to a smaller model, you will improve its latency by a lot. But you can see that your parser is almost like taking a lot of time, like it's almost 200 milliseconds, whereas your model is taking 500 milliseconds, which is not like the parser itself is just taking a while. Or even this lambda function is just taking a while. So maybe you can, instead of like changing your model, you might think about optimizing your lambda function, or your parser basically. Otherwise, you have a large data, you have traces. I don't know if you saw the traces before, how it looked like. I think it looks like this, if I'm not mistaken. Yeah, something like this. So you get a lot of these, and you have to manually go there and like make a sense of these traces, which is not ideal. It takes a lot of time. So if I want to debug a system like this, which has, if you can see, it has lots of calls, right? So, and this is, we are only talking about just one operation in the system. And as you know, we have lots and lots of operation just for one call. And if I want to debug the whole system, it would be very, very hard. So you only get the last error message, but you don't know where it is coming from. And that's the value of this. So, and it can easily like filter things out as well. So for example, you want to see um, the calls that took like the median of the latency. What is P99? What is P50? Or you want to just filter the ones that gave you an error. I think there is something here to filter those as well, because I know Langsmith has that. So you can just filter those, or you want to just create a dashboard. You can easily create a dashboard out of these traces. But yeah, that's how the platform looks like, and how it can provide a lot of value. But just let me know, like, do you want me to go maybe deeper? Do you have any questions about Arise? And I can talk about the alternative as well. So the alternative of not having a platform for traces is logging everything in state, right? So we have a Flink worker with state, and the state on Flink is just the conversation history, for example. So the transcripts are coming in a streaming manner, and we want to grow it over time. And for example, the other thing that that is in the state is the extracted situation. So you want to For example, compare the new extracted situation with all of the previous ones. So you need a state. If we don't have a platform for traceability, what we need to do is we need to log everything in the state. All of these, for example, mini calls like the parser, the lambda, everything with the latency, the output of the function, the input of the function. We need to log everything in a state, which is a lot of work, to be honest. Like creating that granular state is a lot of work. And even if we create a state like that, it would be a nightmare to query. Like, how do you want to query that? You have a session ID of the call, right? And you can see all of the state, but it would be a very big file. It's not visual. So you cannot click easily like this platform to understand which one gives you the highest latency, which one gives you error, all of that. So that's about the alternative. And also, I wanted to show you Phoenix. So Arise is the enterprise. It's third party. It manages everything for you. You don't have to worry about anything. But they have a Phoenix platform, which is this is open source version of Arise. So this Phoenix also gives you traceability. It has a similar kind of UI to it. It doesn't have all of the features. Obviously, it's not multi-user, or you cannot share it with anyone else, or it doesn't have these cool filters or dashboards, things like that. But it just gives you the basic functionality. And you also have to control and manage everything on your own, which is creating the clusters and Kubernetes, all of this stuff. So I'm gonna say Phoenix Rise. So if you want to take a look into Phoenix Rise, this is the open source platform. I don't think that I have it on my Dockers. If we can definitely like have another session just to go over Phoenix. I don't have it on my Docker, but I can just spin up a Phoenix kind of yeah, it's a Phoenix demo. I think this is cool. Yeah, this is actually how it looks like, and it has the traces as well. Like if I go here, this is a Phoenix demo. I don't know. I think I found it somewhere. Uh, this is how it looks like if you want to host it your own. It doesn't have all of those cool features with the filters and everything, but it does have this capability that you can see the LLM, the embedding, the retrieval step, and you can also have evaluation. So you can have different labels, and it automatically give you scores here, and you can connect it to a dashboard, and you can see in overall what is your correctness or hallucination looks like. So does anyone have any questions regarding Phoenix or RG in general? Yeah, Niraj.
Yeah, so I have questions. I don't know. Should I start with RAG? So just I'll start with the Arise one. So basically, Arise traces every single uh, call, LLM specific call, or like RAG calls as well, that we are building for, let's say, Agent Assist. This is not just evaluation, right? It's you're tracing each individual call of the process, right?
Yeah, so all of these traces are coming from LangGraph or LangChain. So LangChain automatically create all of these traces for retrieval, for embedding. So you can break it down. All of the latencies are automatically. So whatever we put in LangChain and LangGraph, it will be here as well. So the retrievals are here, the embedding, how like we retrieve the document so you can see what was retrieved. Then in generation part, you can see the chains, what happens in each step, or what are the pre-processing step, everything else. So basically, it's just everything that is in LangGraph and LangChain.
Jayad, you can go ahead.
Oh, I wanted to kind of ask a related question. So if I were to decouple this, the logging itself is enabled by which package? Sorry, can you help me understand that piece?
So there are multiple logins happening. So this is useful for AI engineers on the team, right? We have multiple levels of, like, the system has multiple levels, right? So we have Flink, which has state. It is also logging a lot of things.
Yeah, I'm
But
talking about like the RAG logging.
the RAG, yeah. So the RAG is when you're coding on LangChain or LangGraph, they automatically create these traces, right, for each step of your chain. So you have a big chain that does a lot of different steps in LangGraph or LangChain. So it does create all of these traces, and this product here is just a way to filter, dice the data, filter it, and visualize it.
Got it. So I just want to decouple that very, very quickly also. So
Yeah,
you use that for logging the traces and persisting that data, right? So that
exactly.
persistence of that data itself, it sits like in a Google Cloud Storage bucket or some database.
Okay, so there are two different choices here. If you want to go with Arise is completely managed, right? So you're basically sending the data to Arise, and Arise manages everything else, right? So you don't actually, the storage is not on Dfinity's premises. I think Arise can also use Dfinity's, use Dfinity's storages. Probably it can, like, if you request, we want to like on-prem kind of version of Arise, they probably can accommodate that. But this is like, if you just go with Arise as is, it just keeps all of the storage and all of the data in their storages,
Got
their
it. So you'll
cloud
be
platform.
directly logging
Yes,
to their system. Okay.
exactly.
Right.
So it's a cloud, it's a SaaS product, basically.
Right. But I think we have an option to also not go with a SaaS product too, right? Like we can go with a version that's hosted on our cloud too.
Yeah, so again, like Arise can host Arise on your like on-prem environment, right? Or if you want to just go purely with Phoenix, which is open source, it doesn't have all of the features, you can host it your own. So you have the Docker file, you can put it in your Kubernetes, and that's it. Like, you're 100% responsible for everything.
Okay. Thank you.
No problem. Lisa, do you want to go next?
Yeah, I'm just given that this is using LangChain, do we have a comparison on Arise and LangSmith? Like, what would be the difference between the two products? Because from what I'm researching, they seem to be like the same proposition, right? Like being able to consume the trace that LangChain does. Do
Yeah.
you guys have any comments on that?
So they're like almost similar. Like they have exact same features. Everything is the same. It's just one of them has been in the game for a couple of years, so which is Arise. So they have more than just traceability, right? So um, they were in a game before even like the Chat GPT era and everything else. So they have a lot more features. Langsmith is just a startup. Been here for, I think this year they raised their Series A, or even their seed round was like this year. So it is a brand new company. It's a startup, and it just do only just traces. It doesn't have anything else.
Okay, so it's more about
And
maturity and proposition of the
yeah,
data
but in
practice.
terms of for an AI engineer who is only focusing on the LLM side of it, the RAG pipeline, the two platforms are almost identical. There's no difference.
Thank you.
Neeraj, do you want to go
Yep.
next?
So, so the question Javed asked, maybe I didn't understand the answer. So, if we go with Arise itself, they manage everything. But if we don't go with Arise, these traces are still being recorded somewhere and stored.
These
And
traces will be recorded, yes. And
so where would they be stored? Like GCS or?
we can decide on the storage. We haven't had any discussions on where to put these traces, but we can easily. We can also like host the Phoenix, like open source Phoenix, and store it there, like on Kubernetes, the exact same location that everything else exists. Like we right now we have a Kubernetes GKE that hosts Flink, for example. So exactly on the same Kubernetes instance, we can have Phoenix hosted as well, and it will like store all of these.
Would that increase the latency though? Like
It will. So that's the tricky part of using a open source version, because it is completely our responsibility to manage it, right? So we need to optimize it so that it doesn't, but it will increase the latency by a little bit, but it just depends on us on how to tune it in a way that it doesn't affect the latency that much. If we go with the open source version, if we go with Arise, they do everything. 0 to 100 is just their job.
And what kind of errors usually you encounter? Like just out of curiosity to understand, like how would it be like debugging in this type of framework?
Yeah. So
Is it time-based?
Yeah, the error can be from a lot of different systems. So the first system that can go wrong is the retrievers, right? So if, for example, one of the retrievers are off, Agent Builder is not responding, or AlloyDB is not responding. This is the first error that you might get. The second error can be from the LLM itself, like OpenAI, Gemini. Like you will see these failures in their API now and then. So it can happen on the LLM side. It can happen on your parsers. So when you parse the information, you are expecting the LLM to generate in a specific format. But if it doesn't generate in that specific format, something will go wrong. So you might get a failure in that. What else? Yeah, mostly that. So retrievers, the LLM itself, and all of the post-processing, like the parsers and the conditions. For example, you have a chain that require a couple of conditions. So if something happened, then do that. Okay, so let's say if that particular thing never happens, it won't go to the next step. So basically the chains themselves, the logic of the chain can also go wrong.
Do you happen to know how often, like what percentage of error with other clients you have seen high level, like going through this?
Yeah, it just depends. It just depends on the structure. So for Dfinity, we don't have a very complex structures in terms of RAG, and it's because we have a like a we have a constraint on latency. We cannot create a very complex system. So basically, we just retrieve the documents. We go directly to RAG. There's only like the re-rank here that happens between these two. So we go directly to RAG. We go directly to the LLM. But I don't know. So there are like other projects that I was involved in that had a lot more complexity. So it wasn't just directly going to LLM and give you the output. It will it had a lot of chaining. So one LLM go to another LLM, go to another LLM, so things like that. But for Definity, we have a simpler kind of structure. So I don't think that we will have a like high rate of
Rate, yeah.
failure.
Makes sense. So like just at high level, is there like any requirement to monitor this rate, or is it not there? Just wondering,
Yeah,
I'm new to this project. Okay.
yeah, for sure, for sure. You wanna understand, you wanna monitor the failure rate of the RG pipeline as well, because yeah, because the agent will not understand if so the agent doesn't know the difference between if we don't have knowledge articles in the backend or if the RG system is failing. There's no way for the agent to figure this out. So basically, you need to log it somewhere and you need to monitor it so that you actually have an understanding of if like RG is failing or not, because no one else will notice this.
Yeah, no, makes sense. I do have questions around RAG system that you were kind of explaining before. Again, bear with me. Some of these are like basic questions, but so there were so high level. There is no, a RAG system for Guidewire and knowledge base. Will it only pick one or the two, or it can pick both
It will always
for
pick
the
both.
same?
It will always pick both, but we don't query Guidewire multiple times because the Guidewire data is just static. So you have a policy number and you have a data for that policy number. So if the customer just talks about one policy number, you won't query it twice. You just query one time and that's it. But for knowledge base, every time you're querying a new set of documents. So that's the difference.
No, that makes
But
sense.
you always do it. You always do it. There's
So you
not
always, okay.
yeah.
So like your final LLM that is generating output, it would be, let's say if it's the first time doing the Guidewire RAG and it's whatever X number of time for the knowledge base, it will always compare the two and generate a response. So it will always be in the memory to have
So
that Guidewire
yeah,
RAG.
there will be two pop-ups there. So in the
Those,
UI itself, you know which pop-up is generated from the knowledge base and which
okay.
pop-up is generated from Guidewire. So
Yeah,
there are
that's what I
two
wanted to
different
get.
pop-up.
It will pick one or the two, or like will the generation be based on a mix of the two? So that's what I was kind of initially going with it,
Yeah.
but that makes sense now. Uh, the other question, I mean, if everyone had anyone have any other questions, feel free to jump in. Otherwise, I'll continue.
I have one
Yeah, go
question.
ahead.
Good
I have
job,
one
Thomas.
question related to Arise around the traces. You said that it can be really difficult to debug the traces, right? How can we debug it in the Arise platform if we have to?
Yeah, so first of all, if there's anything goes wrong, you get an error message from, for example, LLM, or you get an error message from your parser. It will be
Right.
logged here. So you can easily filter off the failed instances. And also, let's say you have a pop-up that is very bad, right? So it's pure hallucination. And you want to investigate further, you want to understand what happened that you get this pop-up. So you come here and you have the session ID in Arise. A session ID is generated from 5.9 and it will be consistent across all of the systems. Okay, so we send the session ID as a metadata to Arise as well. So you come here, you have the session ID of the call, which is generated by 5.9, you just search it. And then you see all of the LLM calls, like every step of the RAG, and you will even see all of the documents that are retrieved, all of the steps after the document were retrieved, the re-ranker, everything. So after that, you can debug it further. You can understand why that particular pop-up was generated.
Okay. And you mentioned that we can store these traces somewhere in the Google Cloud as well, right?
Yeah, if you go with the open source version, which is Phoenix, you will run it on GKE and it will be stored.
Let's say I don't want to go ahead with Phoenix, for example. I want
Oh,
to
you
just save the traces
yeah
somewhere.
yeah you can. So we can send it with a Kafka to a Kafka topic, and it goes to BigQuery. So
Okay.
exactly the same way that we store the states of link, we will store the traces as well. We can do it.
Okay. Okay. And another question, I don't know if that was answered already. Just one last question, Swapna. I have to drop off for another meeting. But if, for example, would the data that we are getting from GuideWire and from Knowledge Base, would those be like combined together to generate a response in the future, or they would be separated?
They will be separate.
Okay. Thank you.
Yeah, no problem.
Yeah. I have just one question. Like, does Arise also provides any traceability on the vector embeddings from AlloyDB? Can we pass that on?
So there are bunch of things that you will see here. So for example, here you retrieve the documents, okay? So you have an input, and these are the documents that are retrieved, and you will see where which retriever give you which documents. But aside from that, you won't have any other traces. I don't know if you're looking for any other information.
So, so how do we is there any type of similarity search discrepancy or any kind of such like, for example, if I'm accuracy of the similarity search with vector databases like AlloyDB or kind of generates, right? So do we have any visibility on that from Arise?
You mean the score of similarity between the input
Yeah.
and we can do it. Yeah, we can add that if you want. I think there's there's a score here. Yeah.
Okay.
Yeah. So it's already here.
Okay.
So it's just means that 77% was the similarity score.
And this is through AlloyDB.
Yes, it will be true for AlloyDB, but it won't be true for Agent Builder, because Agent Builder, I doubt that they will provide the actual score, because it's just it's a complete service, right? In addition to score, there are a bunch of other things that it will do in the background. But we can definitely check if Agent Builder also gives us the score.
And is there any kind of threshold which we can set for these scores to kind of pass?
We can have scores, but the problem with the scores is like sometimes we think like 70% is low, but actually it's not. So
Okay.
the problem is I like in previous projects I set scores, and I found that sometimes the score that we put is just a number that we think is enough. And also it is changing between model to model. So one model think this is 90%, one model think this is 70%. But do we actually know that like which one to pick? Like the threshold, like setting the threshold itself is very complex.
Yep.
So that's why we don't have a threshold, but we can add it if it's needed. But right
Got it.
now, I don't think it's needed because we have a re-ranker step, right? So
Mhm.
we have like maybe 50%, 50 documents retrieved, and then we have a re-ranker that only gives us the top 20. And the top 20, even if there are a bunch of documents in there that are not very relevant, it doesn't affect our generation step.
Okay. Thanks, Suman.
Yeah, no problem.
I'll leave my questions for next time.
Okay.
Any other meeting. Peace. Bye-bye.
Awesome. Thank you very much.
Thank you. Thank you. This
I-
was very,
I-
very helpful.
Yeah, thank you.
Very
Thank you
helpful.
for, and just let me know if you have any other questions.
Yeah, I do have a lot, but I think we are in meetings every day. So
Yeah,
I'll ask
sure.
at some point. Sounds good.
Awesome. Awesome.
Thank you
Thank
so
you.
much. Bye-bye.
Thank
Thank
you.
you. Bye-bye.
Bye-bye.